All right, I'm going to go through this example. We're given that omega 2 is 10 radians per second counterclockwise. And so I'm going to go through finding all these unknowns that are required on this particular problem. And hopefully that's helpful for the homework. So the thing I'm going to start with is, since I know omega 2, I can answer all these questions that have to do with points that are associated with link 2. Now, link 2, I've got link 2 goes like this, so I can obviously find the velocity of this point v2, which is one of the things I'm asked to find. Okay, and so I can measure that distance, which I get as 4.3 centimeters. So what I can say is the velocity of B2 equals the distance from B2 to 1, 2 times omega 2. Now it's important that every one of these formulas that I write down has a ground point in it, and it has the ground point that's the same as the omega that I'm using. Okay, and so velocity of B2 is 4.3 centimeters times 10 radians per second, and so that gives me the velocity of B2 is equal to 43 centimeters per second. So I can write a 43 right there. All right, now I could also find the velocity of any other point on link 2, and one of the things I'm asked for is, let's see here, I've got omega 5. Well, link 5 is a slider, and so it doesn't rotate, and so it's just going to be 0. Okay, and the reason for that is this sliding joint always constrains the omegas to be the same. So omega 5 has to be the same as omega 1 because there's a sliding joint, and omega 3 has to be the same as omega 4 because there's a sliding joint between those two. Okay, so even though there are different answers there, they really should be the same thing because that's what the kinematic pair there does. Okay, so now I could find the velocity of d, which is a point on link 5, which is a slider. And the way I'm going to do that is I know that the velocity of all the points on link 5 are the same. So I know that the velocity of d equals the velocity of 4, 5, but because it's pure translation, that link's not rotating, all those links are going to be the same, so this is important. That tells me that V45, which is VD, is the same as V25. Okay, and that means it's a point, I can find out the velocity of a point on link 2 that'll tell me what VD is doing. Okay, and so that'll speed things along quite nicely. And so I will have V25 is going to equal to R25 with respect to 1, 2 times omega 2. And so once again, this is 10 radians per second, and then I can measure this distance right here, and that'll be 2.6 centimeters. And so that's going to be equal to 26 centimeters per second. Now, this may seem a little odd in the fact that I'm finding the velocity of this point using an instant center that's over here, and it's just because that's what this instant center means. This is the velocity of a point on link 2 that has the same velocity as a point on link 5, and since all the velocities on link 5 are the same, that works. Now, but that's not particularly typical. A little bit more typical example, might be when we find, say, omega 6, okay? And so if I want to find omega 6 to find how this thing's rotating, I could find, I could do the velocity. If I'm trying to find an omega and I know an omega, then I want to use the common instant centers. So I'm going to use V26 is equal to R26 with respect to 1, 2 times omega 2. And once again, I know that omega 2 is 10 radians per second. And R26, 1, 2 to 2, 6, that distance right here is 4.7 centimeters. And so V26 is 47 centimeters per second. But I also know that V26 is equal to R2616 times omega 6. Okay, I don't know what omega 6 is, but I know V26 because I just calculated it. And so that's 47 centimeters per second. And I can measure the distance from 1,6 to 2,6. And that's just, say, 5.55 centimeters times omega 6. So omega 6 is equal to 47 divided by 5.55 equals 8.47 radians per second. Okay, now one of the other things I got to know is whether omega 6 is clockwise or counterclockwise. And so how I think about that is using the right-hand rule. I know that counterclockwise is rotating in this direction about 1, 2. So that means I know that 0.26 is going that way. And then, so then I think about 2,6 as a point on 1,6, and I know it's going that way, so which means link 6 has to be rotating in the clockwise direction. All right, so once I know omega 6, well, VC is just a point on link 6, and so that's going to give me VC is equal to RC times, with respect to 1,6, times omega 6, and that's going to give me a distance of 4.5 centimeters times 8.47 radians per second. And so VC is 38 centimeters per second. All right, we'll pause there.